In this lesson, I'm going to be showing you how to match the cloud color function to the density production because there are some large scale differences and they are not linked to the cloud. And by default, the color and also the modulation settings, if you wanted to animate them along with the cloud layer, they would stay fixed while the clouds move through them. So if you want them to move together, the tool and function we're going to create will allow you to do that. It'll also allow you to color based on the density. So I have a scene loaded in right now with the finished function, and you can load this in. It's called the Cloud Auto Scale Color function, and that's included with the content in the project content folder. And I'm just going to give you a sneak preview of what this looks like and the different controls we're going to be creating. So I'm going to open up the Atmosphere Editor, F4 on the keyboard, or you can go to Atmosphere, Atmosphere Editor. And then I'm going to select the Fluffy Cumulus, which was the original preset I used to design this function. It'll work with any cloud, and you can end up creating a Metanode to bring it over. And then one thing I want to note is when you go into the density production, it'll only show what is creating the density. Now, to make this really obvious in the way it controls the function, I do have just a very simple object setup for a rectangular noise. And then I've also removed feathers and detail from the cloud so that we just see the density production. And it's really more of kind of a test pattern to show that everything is just lined up and working correctly. And then you can design the node and then import it into the clouds you want to work on. So in order to access the color functions, we can go to Volumetric Color. The other functions that were added are under Lighting and Effects, which is the sky ambient color and the sun ambient color, which in order to activate those, you have to select Force Ambient Color. I also want to note that the cloud modulation settings are set up in the same way that the volumetric color, and those are on the same coordinate system, which is different from the density production. And if you're familiar with the coordinate systems, basically it's kind of set up as two different coordinate systems for the density production. The x and the y are like a standard coordinate where they'll scale with the object, and then the z coordinate is more like the world coordinate, except the scale is matched to this x and y scale. So that way, if you move, and I'm just going to show you really quick, if you move the object, it moves through the functions. You can see that red has disappeared for the alternating blocks, and then we can move it through up until the red shows again, and now the white is lower, and then we'll just get into the red blocks. So it's moving through the scale function, or the z coordinate space. But if we were to move this left and right, then the whole function would be carried over. Because if we go back into the atmosphere editor, edit the layer, and take a look at the function, which looks a little complex. I've gone ahead and colored everything so it can break it down into the individual parts. And I'll explain what each color means and what it controls and why it's needed. And as we build this, we'll be just kind of going over the overall scale and then taking a look at the orientation and then some auto scaling. There's a few things that are not dynamic that do need to be keyed in manually, and that depends on whether or not you're using the auto scale, which I have turned off right now, and the Z function scale for the density needs to be keyed in. Okay, so let's take a look. The position, everything that's controlling the position, although some of it is connected to other parts of the function, I've tried to at least color them to a point and show the why they are connected. So if we take a look at the dependencies, that's another thing we need to enter in if you're using this as a metanode. You'll need to enter the size object, or the size of the cloud object, which says fluffy cumulus, and we've got the size, position, and the orientation. I'm also using relative to parent, which will be important to make sure that the scale is working correctly, and then the position and orientation are kind of matched properly. So it does make it a little easier. And there's just one thing I forgot to color in, because that's part of the auto scale. Okay, so red is the position, and the world position along with the material position. And this is the material position right here, which is the same you would have for the density. So the density is over here, and you'll note that it says transparency for the output. It's actually the density output. And then the green we have here is the orientation, which we can use and have it directly connected to the object to control the orientation on the position. The orange nodes are for the auto scale, in order to match the scale to the auto scale function, which will size the entire object or the entire volumetric space up and down depending on the height of the cloud. Up top, we have the auto function scale. Now the auto function scale is to match this function scale for the density production. The Z is the number that needs to be tied in and entered manually, just because depending on how you manipulate the cloud, it's not always going to be an accurate number that can be dynamic. The X and Y is calculated based on this number, and if you were to go into the atmosphere editor and modify the height of the cloud, it changes the internal units and really messes everything up. I mean, if you want to, you can set it up dynamically. Just make sure that you don't change the altitude within the atmosphere editor. But that can be difficult to maintain. The yellow nodes are the ones you have to manually enter. So this is the auto scale here, which is a checkbox. Then we have that Z coordinate, and then there's also one more scale, which is the material scale, and that's the scale that shows up within the atmosphere editor for that cloud layer. So that also needs to be keyed in. Once we move over here, we've got the purple, which is the coordinate match for matching the scale between the two systems, because the color and modulation settings are a world space, and they pretty much stay fixed. So this allows you to manipulate everything to match up to the density. And right here we have the rectangular noise, which is the same settings between the two. So now they're matched, although the preview will not show up because this is based on the density scale still, and the manipulations to the position are not accounted for. One thing you can do is go to the preview options, set it to 2D plane, and then select the object scale to 10 kilometers, and that'll show you what it looks like. Although I do want to note that currently, or at least the version I'm using, none of the preview settings are going to be saved with the scene. So a little bugged right now, just the function previews. So even if you change the previews in the nodes, once you load the scene back in, everything will be reset. And then the previews on the what we just set with the preview options, that's pretty much reset every time you close out the function editor. So once I reopen it back up, you can see that it's back to where it was. So by breaking this up, it makes it a little easier. When we want to create a metanode out of it, we can take the individual sections and create different metanodes and then group that all as one metanode. But right now, I'm just going to keep it all open, and we're going to start designing this, and I'm going to show you how you can set this up. To build the function, we're going to start with an empty scene. And first, we're going to go to Atmosphere, and we're going to add a cloud layer. And actually, I'm going to go ahead and delete that. And within the Atmosphere editor in Clouds, I'm going to go ahead and load it in. And I'll start with what I had in my version that I already created, which is the fluffy cumulus. And we don't have to modify the density just yet. There is one thing I want to note. If we go to File and Options, I have Preserve Size of Natural Elements checked. I'm actually going to go ahead and uncheck that. Delete the cloud and load it back in, and that's going to give us a scale that's a little more accurate to the scene scale. We're now going to edit the material for the cloud, and we're going to drive the volumetric color with a function. So one thing we have is the dummy object along with a vector coordinate for randomness. I am going to suggest that you don't use the randomize button, which is located in the material in the atmosphere editor. Right here, if you click on this randomize button, it will input a random vector. I was unable to find a way to get whatever coordinates are in here match to the color output. And I think it has to do with it existing in a different scale, because in previous versions it worked properly, but the output was so minimal that it barely had any effect on the cloud because it was based on the world and not the object scale. But finding a way to match them up, I found very time consuming. I was not able to find a way to easily do it. So what we're going to do is match a color to the density of the cloud layer using the existing noise. And it should be a rather interesting effect. What I'm going to do is copy and paste this noise, and we're going to go to color, right click, go to color, and select color map. And I'm going to use something with a lot of color, just so we can really see the changes. This probably isn't something you would use for production use. What I'm going to do is go to the color map, right click, actually, we'll double click on it to load in a map. I'm going to go to my color maps and load in my wavelength color map. And then connect that to the terrain Perlin noise, which might have an output. It looks like it has an output that's beyond 1 to 1, just a little bit. The color map works from scale from 1 to 1, or 1 to -1, and this is going just beyond it, but that should be okay. Now I'm going to connect the volumetric color to the map output. And what we're going to see, if you take a look at the preview, is just a really, really small version of this noise. So I'm just going to render that really quick, just a quick preview. So we can see in the render, it's mostly just grain. It looks like grain because it's just so small. We'd have to zoom in quite a bit to see it. So obviously there's a huge change and a huge difference between those scales. Luckily, this is a fixed scale that could be very easily modified, which is great, because if it was dynamic, it'd be a lot more work to match it up. So the initial scale difference is really pretty straightforward. So the difference in scale is 2,000. It's 2,000 times larger, the volumetric color, 2,000 times larger than the density output. So this is going to be pretty simple to modify. Because we'll end up with separate position inputs, I'm going to go ahead and copy and paste and create another position input just for the volumetric color. And we'll go ahead and just take the density and move that up and kind of out of the way. So in order to modify the position to match, well, one thing we could do is just type in a wavelength that's 2,000 times larger than the current wavelength, but then you're going to have to keep modifying things, and it's not going to work well with the dynamics we're going to add to it. So what we want to do is divide the input. We're going to go to Combiner, and we're going to select Divide, because this will allow us to work with vectors, because the divide filter is just a numeric. So what we want to do is add in a constant node, and we're going to add a constant vector. It doesn't need to be a connectable constant, because we're not going to connect it to anything. And we're just going to go ahead and type in 2,000 on the X, Y, and Z. We're going to open up the division. And what we want to do is connect the position for input 0 and input 1. We're going to connect to that constant node. So now our output we can connect to the terrain Perlin noise. And now if I refresh the preview, we can see that the scale is matched. Now, it's not going to be perfect to the density, and that's because the density is modified by the feathers and the detail amount within the cloud tab. So the detail is going to subtract from the density, and depending on the settings, sometimes it can add to the density. So it will modify it a little, so it won't necessarily be perfect unless you remove these values, but then you lose a lot of detail in the cloud, and then you have to rely on a more complex density production in order to get the detail back. But the internal detail amount in feathers will render quicker. So it is going to be off just a little bit, but it gives you a rough idea and the overall output. Now, one thing and one reason it's not matching perfectly is that the orientation has not been accounted for and hasn't been tied to it yet. So there's no rotation in the volumetric color. And by default, all clouds are at a 45-degree angle. We also haven't compensated yet for the material scale or the function scale, which is another reason why it's not going to match up perfectly yet. So there's a few more things we have to do in order to get just that initial setup working properly. First, we're going to go ahead and modify the material scale to this, and then we'll do the orientation afterwards. So what we need to do is add in a constant, and we're going to add a constant number. And I'm going to go ahead and edit the color of this to be kind of a yellowish color. And this is going to be the material scale, which is currently 1.5. So what we want to do is multiply which we're actually going to use that as more of a division. It'll require less node setup and less values to have to type in, so we can just type in 1 and condense everything. So before we make that modification, what we have to do is divide this by 1, or 1 divided by this number. So we're going to add in another constant node. We're going to use a constant number of 1. And then what I'm going to do is add in a filter, and we can use divide. So our input is going to be the constant of 1, and open up the additional parameters, and we can divide it by the material scale. So now what we want to do is we can add in a math node multiplied by a constant. That way we don't have to go through each individual vector and modify it. So we're going to do this after, or before, the overall scale change. That's going to be pretty much the last thing that we do. And we're going to go to the position. We're going to select the input, and connect these. Oh, and I'm going to undo that because I have to open it up first. Go to input 0 and connect that to the multiply. And then actually open that back up, and we're going to multiply it by this new setup we just created. If we open up the function node preview, before we had 1.5 entering it, and now we've got a fraction of the value, which will allow us to basically divide. We can close that up. Close up our division. So now as we adjust the material scale for the cloud layer in the atmosphere editor, we can go in and key in the correct value and the same value in here in order to line it up properly. Let's take a look at the preview. It's going to get a little larger now. And now what we want to do is match our orientation. So for this, what we want to do is add in input external dependency, and we're going to select the cumulus orientation, select relative to parent, and we're going to be modifying the position with this. Sorry, the orientation. And we just need the Z orientation. So if we go to the orientation, the numerics tab, we have a yaw of 315, which is the Z axis. So we just need the Z out of here. So what we want to do is go to math, and we're going to go to vector operations, and we're going to use decomposer 3, which is going to break down the vector system down into 3 numeric outputs. So if we open this up, we can see we have X, Y, and Z as numeric outputs. And we're going to use this to adjust the angle, because our output is going to be the angle of this position here. And what we need to do is go to math, back to vector operations, and what we have is axis orientation transformer, which gives us an angle and a direction. Direction is going to be the position, and then the angle is going to be that Z. And now we can connect our multiply to the output of the axis orientation. And we can see once it starts cutting through the layer, we can see how it goes deeper, and that color map is going inward into the density, although we still haven't compensated for the function scale. So the overall stretching that we're going to get from the function scale hasn't yet been applied. So I'm going to go ahead and change the node color to green, and that way to separate it and give the orientation its own color. Actually, we'll go ahead and brighten that up just a little. And now we can go into this color, we can copy it, and then we can paste it onto the nodes that affect orientation. And then I'm going to go to the nodes that control the overall size, and that's scale fix. And I'm going to change that to more of a purple color. Copy it, and just move that over. Go ahead and paste that onto our other values. Now, because this is a dynamic change, we're going to keep that as the yellow, and that way we know which nodes are going to be essentially published in the end. Then we'll be able to access them directly from the material editor rather than having to go into the function every time you want to make some changes. And then we'll go ahead and take this multiplier and go ahead and paste that color in as well. And starting now, I'm going to go ahead and modify the position inputs to red. And there's only one right now, but as we start making modifications to the position, it'll be a lot easier to see which ones are having the effect. And I'm going to be saving incrementally the different steps. So at this point now, I'm going to go ahead and save it. And then I'm going to create a new incremental save for the next portion. Now we're going to be going back into the function and working on the function scale controls. So if we go to the atmosphere editor and edit the material, we have the density production scale. Now, if we were to look at the scale parametrically, the Z scale is going to be the overall object scale, and what would be equal to 1 as a parametric. So whatever the Z is equals 1, let's say, like material unit, where the unit is the size of the box or the cloud object. So if Z is 2 and X is 2 and it's the same, we actually end up with basically the X and Z being 1 and then the Y being 0.5. Once we start lowering the Z, if the Z is 0.5, then the X scale is more like 4. And the object itself transforms differently because of this, and that's one of the reasons why the Z has to be programmed in manually. I also want to go ahead and turn off auto scale clouds for now, because we haven't built in the auto scale controller. First we need to set up the fixed size. So we're going to go in and actually to the volumetric color, go to the function, and what we need to start with, we're going to add an input node, external dependency. I'm going to move time out of the way. And we're going to change this to the fluffy cumulus size. What I also want to do is make it relative to the parent. The reason for this is because the orientation of the object will affect the scale. And then the size acts more like a world coordinate. So if you rotate it, say 45 degrees, on the z, then let's say then the y and the x will basically become larger than the actual object scale. So making it relative to parent is going to give us the local scale, so regardless of the orientation. So with this output, when we do that, we actually get half of the scale than the actual cloud. And that's because the view internal unit is half. So if we go into the numerics tab and the size for the fluffy cumulus, we can see we got 2 kilometers, 1 kilometer, 2 kilometers. If we turn off the dimensions, the true dimensions, and take a look at the view internal units, we have half of that. So we have 1,000, 500, and 1,000. So what we need to do is multiply and we're going to add in a math node, multiply by a constant, and we are going to multiply it by 2. Connect that to the scale. And I'm going to give myself a little room here, so I'm going to move these nodes up and get that origin out of the way. I'm also going to go ahead and start coloring these just to make it a little easier. And copy the color and bring it over here. Okay, so what we need from the size is just the x and the y, because we're keying in the z manually. So we're going to break it down and break down the vector. And one thing I just noticed, I'm trying to right-click and open up the menu, and it's not working. And I think that's because I'm inside of where the node would be when you expand it. And I think that's why it's not working. So if we go outside of the node from where it would be if it was expanded, then the menu will show up. So if we go to math, we're going to go to vector operations and decomposer 3, which is going to break down the vector into x, y, and z numerics. Expand. Now, we are going to use the z in order to calculate the difference and change between the x and the y, but the output scale is going to have to be that manually keyed in entry. So we're going to start by adding in a combiner node and setting it to divide. Since we're working with numeric output, we could also use the divide filter. But I'm going to use the combiner node. And what I want to do is take x divided by z. And then we're going to create, and I'm going to go ahead and just copy and paste that node. And then what we want is y divided by z. So next we're going to add in a constant node, constant number, and this is going to be our z scale, which is currently 2. So we'll type in 2. And because this is something we key in manually, I'm going to go ahead and add a color to that. So next what we need to do is make an adjustment for the z scale so that these work correctly in the outputs. So I'm going to add in a math node, divide. And this is another one we can use, and I'm going to be using different types of divisions just to show you some of the options you have available. So what I'm going to do is take what would be the x output here and divide it by this constant node and the z scale. go ahead and copy and paste it. And then I'm going to replace where the x was and replace it with the y. So then we've got y divided by z. And the reason I'm using the division is because just like we did before with the other scale, we are going to be dividing with the multiplication on the vector. So we do need to have one last set of nodes, which is going to be 1 divided by the x, y, and z. So I'm just going to add in a constant node number of 1, and then we can connect all of these next nodes to this one and use that value. So this time let's use filter, set it to divide, and we're going to divide by 1, or actually input is going to be 1, and then we're going to divide by the x, y, and z. So I'm going to copy and paste 2 versions of this since that other part is connected. So the bottom one, we're going to divide y, and then we're going to do z, which is the one we key in manually, and then x. So these aren't in order, so we just need to make sure that when we connect this next node, that we're keeping that in mind, that we've got x, z, and y. Just because I'm trying to keep it a little cleaner and separated so that things make a little more sense. And I'm going to move this origin up once again, just to kind of get it out of the way. So now we have our outputs to control the scale. Right here, our position. I'm going to go ahead and move these over to the side. And we're going to need to modify these after the initial scale change, but before, or actually set this before the initial scale change, and then also before or after the orientation. So remember, we're working from left to right. Okay, so we need this connection here. Just going to shrink these down just to organize that a little. And then I'll just go ahead and move all these over a little. And you can close up the decomposer now. So what I'm going to add in is, because we're going to be multiplying, as I was saying before, we're going to use the XYZ product for this. So if we go to Math, Vector Operations, there's XYZ product, and there's also the XYZ product separate parameters. What this will allow us to do is use the X, Y, and Z as inputs. So that way we don't have to use decomposers or a composer 3 to form it back together. This way it's just a little easier. So X on top, Y on the bottom, Z in the middle. And then what we're going to do is take the input and connect it to the orientation output. And then where we're outputting that before is to this multiply by. So we're going to take that input and replace it with the XYZ product. So now our function scale will be correctly matched. The only thing we have to do is just, if we update and change the scale of the cloud object, then we need to go in and key in the Z scale. So I'm going to go in and assign these colors and clean this up a little. We can shrink down the nodes. Things we're not going to really be changing. And then I'm going to go ahead and save another incremental copy. And now we can get started on adjusting the position of the function to match the position of the object. So right now we've got the function scale working correctly. All the scale stuff works fine, except for the auto scale isn't set up yet. And then we've got the orientation, and then the overall scale changes. And now we're going to add the position part of the function. Go ahead and open up the atmosphere editor, edit the layer, go back into the function here. And what we need, first of all, is an external dependency. Add input, external dependency, and fluffy cumulus position. Make it relative to the parent. And I'm going to go ahead and give it a color. Now, you could also use the dummy object position, but I find there are some problems with it sometimes. So we're going to create a new external dependency for this. Now, because we're going to be using the object position and the Z, what we want to do is pretty much remove the Z-axis, or at least fix it, so that we can control sort of the origin with the object. So we will eventually be adding in a projection onto plane, which sort of makes it like a flat view. Sort of the way the terrain editor works, where it takes more of a slice. But we'll get to that. I'm going to go ahead and move the orientation controls down below and give us some room to work on the position. And we need two things to calculate at least the Z position. And those are going to be dependents of the size, because the position output is basically half of the size of the cloud height too high, where it kind of slices it. But first, let's go ahead and just get the X and Y sorted. And for that, what we need is an offset node. So we're going to go to Math, Vector Operations, and we're going to use Offset. So we're going to be offsetting the position, the material position, with the external dependency. So we're going to connect the direction to this offset, and this to the position. And now what we're going to offset it with is the position. But the way offset works is if you enter a value of, say, 100, the position is going to change by negative 100. So we need a negative value for the offset to be fixed to where the actual position is. And basically convert the offset into an origin. So what we want to do is this is a really easy way to just flip it around. And it sort of works as the opposite filter for numeric entries. We're just going to connect this to the external dependency and add this into the link and multiply it by -1. So now we have it flipping around to offset it properly. So the Y and the X should now properly show up where the object is positioned. So we can just go ahead and check, and we're gonna take a look at the light, or the cumulus cloud here, and we can see. Just gonna go ahead and move it, and we can just taking a look at this little purple bit and seeing how it moves and matches to the X and Y. Okay, but the Z probably won't work just yet. And it's probably not going to line up. And I'm going to set the altitude back to 2 kilometers. And if you take a look, I just set it to 2 kilometers, but the output is right here, Z 3.5 kilometers. And if we take a look, we can see the height. And actually, that hadn't refreshed yet. So sometimes when you make a change with the panel still open, you need to go to the numerics tab and I'm just switching to the aspect and then back to numerics. And now we can see the height is 3 kilometers. So basically what we have is the altitude plus half of the height, because the pivot point and the focal of an origin of the cumulus object is in the middle. So the position is off by half of the height. So we need to correct for that. So we'll go back into the atmosphere editor and go into the function. And what we're going to do is first take half of the size. And we could use this decomposer over here, but I want to keep everything neat, kind of the way I had it before. So I am going to add another decomposer to the size. And because we're now getting what we need as far as a value and output, which should be 1.5, or sorry, 1, because it's 2 kilometers in height, we don't need to multiply it by 2. And what we're going to do is add Metanode vector operation offset. And I'm going to separate the parameters because we just need to offset the Z. So I'm going to set the X and the Y to 0. And we're going to connect the Z to the decomposed Z. And then we can add this to our connection here for the position. Now, this isn't going to work just yet because we also need to take the existing, or the position from the object, and add that. Because right now we just have the size determining it. So I'm going to take another decomposer and connect it to the position. And then I'm going to subtract the Z position from the Z scale. So for this, I'm just going to use a combiner, set it to subtract. First select the Z, the position decomposed, and then the scale. And then we can connect our Z to the output here. And close these up. And we do need to reverse this because we are working with an offset. So what I'm going to do is use a filter and divide. And I'm going to go ahead and divide this by -1. So connect our Z and divide by -1. And that should line us up properly. And as I was saying before, I don't want the position of the material messing up what we've got here. So I am going to add projection onto a plane, math, vector operation, projection onto plane, and then have the Z, which is going to be C, sort of flatten out. So the X and Y show up and it sort of slices the rest. And then as we move the object, it'll move through that slice. And now we should be able to move through the function. There's another thing I want to note, and that is the z coordinate system for a cloud object that isn't auto-scaled is going to move through the world space. So now we have it set up so that the position it's moving through the world space on the z. The x and the y is not world space. It's not going to change when you move it. It's all world space for the z. So x and y is parametric and z is world space. So as we move this, we're actually moving through the function, which is why you'll see the density change. And that's also going to change our color function that's moving through our noise. And I do just want to make sure, and go back into the function, that I do have relative to parent turned on for the new nodes. And I do. So I'm going to go ahead and just organize these and assign the colors as I did before for the proper layout here so you can separate everything. I'm going to go ahead and save another version of it incrementally, and then we'll move on to the auto scale. Before we move on to the auto scale function, there's actually one or a couple of changes that need to be made. One thing I overlooked and another thing that I actually entered in wrong. So if we go into the function, the main thing is, and I kind of noticed this before when looking at the render preview, but it was hard to tell because we're using just typical clouds and not just like a simple shape. And that is in the middle of the function controller, the auto function scale, I have two divides right here, and they actually should be multipliers because we do want to multiply the value by the z and not divide it. So right now we've got everything way too small. So all we have to do is just change these over to multiply. We can just multiply the inputs. And that'll fix that. So the scale should work correctly. We can already see it transitioning into the cloud a little better. Another thing is, if we go to the axis orientation, I did forget to set the angle unit, where it's right now it's set to radian. We need to change it to degrees. And then everything should be working correctly from there. And then we can move on to the compensation for the auto scale. One thing I want to do, just so we can double check everything, is to switch these over to math pattern rectangular for both of the noises, for the density and the color. And then I'm also going to replace the color map with a red and white color. Zoom out a bit. And actually, there's one more thing within the axis orientation. You can see it's not lined up yet. So in the vector operation for the axis orientation, under z, we do need to make that negative. And now it will line up properly. And if we go into the color map, what we'll see is white for the higher density areas, but because of the position of the cloud right now, it is going to change that. So what we should be able to do is move through the function. You see now we have white. Move it down a little lower and we'll start to get into the red, which is the opposite checker pattern. The auto-scale option for cloud layers has two primary differences, and we're going to go and take a look in the atmosphere editor, and we're going to turn on the auto-scale clouds. And we're going to see that immediately we have a scale change. And then our color function is not going to line up because we haven't added the auto-scale options yet for the color function. But the main difference is once you start raising the elevation, the overall scale of the material will change. So as the clouds get lower, they shrink more and more. And that really starts around 1.5 kilometers. Another thing is the Z origin for the material stays the same. And when you move the cloud up and down, it does not move through the world space. It is fixed and becomes parametric. So, I'm going to go ahead and open the atmosphere editor, go back into our function, and we're going to add in our changes that we need to adjust this for auto-scale. And then we're going to assign it to a switch, which we can just check, and then it'll automatically switch it over if we're using the auto-scale function. Since we want to create a tool we can use over and over in different cloud layers. So we're going to start by creating what's going to be the switch. So we can add a constant, connectable constant, or actually, it's not a connectable, just a regular constant, a Boolean number. Now what this does is it outputs a value of -1 or 1. -1 by default, and 1 if it's checked. So what we're going to do is create a blender node, a combiner set to blender, and we can use that to connect to the switch and then swap over the values that we need. So to adjust our scale relative to the position, what we're going to use is the subtracted output, where we have the Z position subtracted by the Z scale. And because our starting point for the scaling change between the auto-scale and with the auto-scale off is about 1500 or 1.5 kilometers, we're going to create a constant number of -1500 because we're working with meters. And what we're going to do is divide that Z output from here by -1500. So we're going to add a filter and set it to divide. We're going to select our input for the Z scale and position that's connected, and we're going to divide it by -1500. So we're going to use this to modify our scale change, and we're going to just modify the material scale. And we're going to use a multiply combiner node. So go to combiner, multiply inputs, and we're going to multiply the material scale by our new number based on the position, the Z position, and the Z scale. So this will be our output for modifying that for the auto scale. And I'm just going to go ahead and change the colors really quick so we can separate this from the rest of the function. So now we need our switch, which is going to be a combiner set to blender. And now we have our two options, 0 and 1. 0 is going to be that default scale, and 1 we're going to connect to the modified auto scale. And then what we want to make sure we're doing is clipping the ratio 0 to 1, because we want to cut out the switch where we have 1 to -1. Well, if we have it set to -1, then it's going to create some problems with the number. So we just need values to control the ratio between 0 and 1. So input 0 to input 1. So we're just going to clip out 0 to 1. And then what we could do is connect the switch. And we'll have to open up the additional parameters and connect the ratio to the Boolean. So once that's connected, we can adjust our input to the division to our new switch. And I'm just going to copy the color over. And what we can do is turn it on. So now our scale is going to match up. And we can go ahead and modify. Oh, and if we go too low and all the way down in the bottom, where it's touching the ground plane, it basically becomes so small you can't see it anymore. So now we can move through the function. And everything's all scaled up. Now, depending on the position you initially started with, sometimes what can happen is we would have the red boxes showing up in this case. So if you need to reverse it, you can either reverse just the color map for the output, or what you can do is go into where we have this multiply. Actually, the divide. And right now it's set to -1. And sometimes when you change that to 1, it will flip it. And it looks like the conditions currently just aren't set up right for that. But if you do have a problem where you reach a point where you're lowering it and everything kind of switches over depending on the scale, it's really going to be dependent on the layer you're using and the different scale options. So if that does happen, you can go in there and modify the division, setting it to 1 instead of -1, or you can just go to the color map and flip it. And now I'm going to make a new incremental save, and then we're going to create our reusable Metanode. So we're going to save this. Actually, we'll save it first, and then save it as 6. Now, currently in the version I'm using, it might not change the title, so I'm going to go in, and just by selecting another file, then the title shows up, and we can just change that over to 6. Hopefully they'll have that fixed soon. And now we're going to go back into the atmosphere editor and create our reusable Metanode. And what we can do is select the entire function that we designed and go ahead and click Create Metanode. And now what we want to do is go in and publish our parameters. And I'm going to start by publishing, just going to the material scale. And we'll go ahead and create a group and just call it material. And then we're going to go, let's go to the Z scale and publish. material function z. And then we just need to publish the auto scale. And we'll put auto scale cloud. And the last thing we're going to publish is the external dependencies so that we can easily assign cloud objects. Actually, we do cloud object. And then we can set this one to size. And then we'll publish the position. And then the orientation. And now we have that published in our Metanode. And then I want to publish some of these parameters to the material editor. So we'll do the material scale. And we'll do function z, and I'll do function z scale. And then the auto scale cloud. So now in the material editor, we have our published parameters, so we can easily and quickly go in and update those as we make modifications to the cloud. And if you want, you can also go ahead and publish the external dependency if you want to just be able to modify the cloud layer directly through there. Otherwise, you can just set it up so that you have to go into the function editor and update that. Because once that's updated or assigned to the object, you really won't be going back and modifying those nodes at all. And since that's available within the Metanode inside the function, it becomes pretty easy just to go in and modify the cloud object. And I'm going to go ahead and assign a color and see if maybe that saves along with it. And then we're going to save the Metanode. And I'm going to add this to math. And I have some other versions in here. But I think this one's better than the others. So I'll probably move these ones to a backup folder. And we're just getting a few errors while we move these around. And we'll go ahead and name this. And so I've just got Cloud Scale Matcher, and I've got it set to version 1.0. We're going to go ahead and save it. And I'm just going to create another incremental save. Save it as cloud function scale 7. And I'm going to go ahead and create a new scene. And we'll go ahead and go to the atmosphere editor and add in a cloud layer. Let's use the dark cumulus. And then we'll edit the material. And now we're going to use the Metanode to fake a higher layer of clouds, their shadows casting onto the object, which works better for sort of overcast skies, so we can fill in these clouds a little more. What I'm going to do is go to the math nodes and Metanode, load in the cloud scale matcher. And we have the material scale at 1.4. And if we take a look, our Z scale is 2, which is entered in there by default. And then we're going to go to the dark cumulus and select size and position, and then the orientation. And what I want to do is just add a noise node, and we'll do a Perlin noise gradient, connect that to our scalar, and then modify the color. Actually, we'll to add in a color map. So go to color, color map, edit that, and we're going to change this green, that's the default, to black. And I'm also going to go to lighting and effects and turn off the force ambient light color. And we will have to republish these parameters if we want them in the material editor. And I do want to get a quick preview of the scale. And what I'm going to go ahead and do is change that a little. What we can also do, actually, is go to lighting and effects and turn back on the force ambient light color, and I'm going to connect these to that color output as well. And if we need a better idea of how the color map is affecting this, I'm going to go ahead and go to the color map and just copy the current color map, and then load in something a little more colorful. And that'll give us a better idea of the scale that we're getting. Yeah, well, actually, we'll go ahead and bring that up to 0.3. And then we can go back to the color map and we can paste it. These are kind of dark clouds, so we may not see the shadow as well, but we can increase the density, or sorry, the cover. It's also a little harder to see because of the gamma is set so high. So I'm just going to turn off the gamma correction. And we should be able to see that a little better. So that's kind of an easy way to fake cloud shadows. And in this case, you probably wouldn't want to connect the position, mainly if you're animating the cloud. So what you can also do is create another object to control the position and, say, the orientation. So what we can do is add in a cube. And what I'm going to do is add this to a new layer. And we're going to hide it from the render. And I'm also going to hide it from the scene. And we'll go ahead and move this a little bit. And we'll go ahead and just scale it up to give a better sense of the size. And I'm going to go ahead and increase that to 2 kilometers. Make it a little bigger. So now what we can do is go to the dark cumulus, edit the layer, and go back into the function, and now in the Cloud Scalar Metanode, we can connect the position to the cube and the orientation to the cube. And then what we can do is animate that separately by animating the cube. And I guess we don't have to hide it from the scene if we have it up that high. It will not render because we have it turned off by clicking on the icon. And this essentially works as a null object. And then we can control the orientation separately. And if you want, you could also set the size to this as well. So you can control the size separately just by modifying this null object. And if you wanted to too, you could also just set up an object that's equal to the scale of the dark cumulus as sort of a starting point, and then modify that instead of modifying the dark cumulus. So having null objects can be quite useful, especially if you want to animate the color settings and the modulation settings separately from the position and orientation, even the size of the cloud layer. So it could be a pretty useful tool, and now you have something you can load in to your cloud layers, and it makes it a lot easier to work with the new color functions and cloud modulation.